Now let's look at the homework that's in section 2.2. Okay, here you're going to list the elements of the set of all letters in the word find. Okay, now, of course, set means that it's going to be the collection of all elements or objects. So here we're going to list all the letters in the word find. So the set is just going to look like this. For the word find, you're going to have F, then I, then N, and D. Each letter is separated by commas. Okay, so the set of all the letters in the word find would be simply F, comma, I, comma, N, comma, D. Okay, now let's look at problem number 2. This one has 4 parts, but I will go over each one of these. You're going to rewrite the following using mathematical symbols here. And these are problems A through D. And we're going to look at each one of these individually. So here's part A of number 2. P is equal to the set containing M, B, Q, and D. Okay, so the way we'll write this is just P, which is what the set is in capital letters, and then that's the equal to symbol, and then we write M, comma, B, comma, Q, comma, D. And those letters or those elements will be in braces. So in this case, this will be this answer right here that I'm going to check off. M, B, Q, and D. Okay, now part B. The set consisting of the elements 3 and 5 is a proper subset of the set 3, 5, 8, 12. Okay, in this case here, let's write the set consisting of the elements 3, 5, which is 3, comma 5. Now the symbol for a proper subset is this. That's the symbol for the proper subset. And then, of course, 3, comma 5, comma 8, comma 12, which is this. So it will be this answer right here, answer B. Okay, now part C. The set consisting of the elements 0 and 2 is not a subset of 2, 3, 5, 4. That's the set right here, and then 0, 2, of course, is the set that consists of those elements. So we write 0, comma 2 with the braces there. Is not a subset would be this. Okay. So it's written like this. This will be is a subset, but when you put a slash over it, it means is not a subset of 2, 3, 5, 4. Okay, so it'll be this answer, answer B. Okay, and part D. The number 0 is not an element of the empty set. Well, we just write the number 0, and then we write the symbol for is not an element, which is this, and it's slashed. And then the empty set will be the circle with a slash over it. That's the symbol for the empty set. So in this case here, 0 is not an element of the empty set, which will be this answer choice right here. Okay, now on to number 3. And we'll look at each one of these individually. Here you're going to find out which of the sets can be placed in a one-to-one correspondence. And of course, a one-to-one correspondence means this, that one element of the first set can be paired with an element of the second set. Each and every element has to be paired with each and every element of that second set for it to be a one-to-one correspondence. Okay, so if we look at part A, can the sets 1, 2, 3, 4, 5 and MNO BT be placed in a one-to-one correspondence? So here, if I write 1, 2, 3, 4, 5, MNO BT, here I can pair 1 with M, 2 with N, 3 with the letter O, 4 with B, and 5 with T. In this case here, each element of the first set can be paired with an element of the second set, like this. So here, this would be a one-to-one correspondence. Okay, now part B. Can the sets BTLM and BTW be placed in a one-to-one correspondence? So here in this case, this would not be a one-to-one correspondence. Here I compare the B with a B, T with T, L with W, but I can't pair M with anything else out of this second set. So this would not be a one-to-one correspondence. Okay? Because every element has to be paired with something in the second set. Okay. Now part C. Can the sets ABC continuing on up to F and 4A12 continuing on up to 20 be placed in a one-to-one correspondence? Okay, now I'm going to write this first one as this. A, B, C, D, E, F. Because we go up to F. And then the other one, 4A12 continuing up to 20. These are just a multiples of 4, so this will be 4, 8, 12, 16, 20. Again, this one can't be a one-to-one correspondence because I got 6 elements in the first set and 5 in the second. I have to have the same number of elements in both sets in order for me to have a one-to-one correspondence. Here, A can be paired with 4, B can be paired with 8, C can be paired with 12, D could be paired with 16, and E can be paired with 20. But I don't have anything to pair F with. So this would not be a one-to-one correspondence. Okay. All right, part D. Can the sets, and in this case, the set of all T such that T is a letter in the word pen, and 1, 2, 3, 4 be placed in a one-to-one correspondence? T is a letter in the word pen. Unfortunately, there is no T in the word pen, so that set is the empty set. And 1, 2, 3, 4. Well, an empty set has no elements in it. So it's impossible to pair something that has nothing in that set with any of these numbers in that set given as well. So this does not have a one-to-one correspondence because an empty set has no one-to-one correspondence with another set that has elements in it. And finally, part E of number 3. Can the sets the square and a upside down triangle and BT be placed in a one-to-one correspondence? In this case, it can. Because I can pair the square with B and this upside down triangle with T. So yes, this would be a one-to-one correspondence. Okay. Problem number 4. Let's look at these. You're given the following sets and you want to determine which pairs are equal. So here we got A, B, C, D, E, F, and G, H, and J. Okay. Now we're going to answer these as either true or false. A is equal to C. Compare A and compare C. For them to be equal, I have to have the exact same elements in A as I do with C. And in this case, I do. Because, number one, they may be in different order, but here I got the A and the G, the J, and the K in both A and C. So here this will be true. Part B, E is equal to F. Here's E, which is the empty set, and F has the element, the empty set. That's going to be false, because these two are not the same. Because F has the element, the empty set. That means that there is something in that set. E just has no elements in it at all. So this will be false. Alright, part C, C is equal to D. Here's C and D. They both have the same number of elements, but the elements in set C are not the same as the elements in D. Because I got letters in set C and in set D I got numbers here. So in this case here, this will be false. Okay, E is equal to J. Here's E, which is the empty set. J is the empty set as well. Here, this is another way of writing the empty set. Just braces with nothing in it. So in this case here, they both mean the same, so this will be true. G is equal to H. Here's G and H. They both have the elements 4 and 1. This is 4 and 1 here, and this is 1, 4 here. Both of those elements are the same. So that's true. And then finally, A is equal to B. Take a look at A and take a look at B. The letters in A are totally different from the letters in B. So that will be false. Okay. Okay, on to problem number 5. List all the elements in the set of all the letters in the word for. Okay, this is similar to the problem that I did earlier. Just listen the letters with the commas there in between. F, comma, O, comma, U, comma, R. Okay, that's all the elements of the set of all letters in the word for. Okay, problem number 6. Again, is a one-to-one correspondence. We'll look at each one of those and answer yes or no. Okay, part A is this. Can the sets 1, 2, 3, 4, 5 and MNODT be placed in a one-to-one correspondence? In this case, it's yes. Because 1 can be paired with M, 2 can be paired with N, 3 can be paired with O, 4 can be paired with D, 5 can be paired with T. Okay? Each element in the first set can be paired with each and every element of the second. Because I have a pairing for each one of those. Can the sets DTLM and DTW be placed in a one-to-one correspondence? That would be no. Because I got 4 elements here and 3 elements here. I need to have the same number of elements in each of those sets for that to happen. And can the sets A, B, C all the way up to F, which is actually A, B, C, D, E, and F, be paired with 5, 10, 15 up to 25, which is actually this 5, 10, 15, 20, 25. And besides, those are the multiples of 5. In this case here, that's no. I got 6 elements here with 5 elements. So that would be no. And then, can the set of all t such that t is a letter in the word pen, which is, of course, the empty set, and 1, 2, 3, 4, be placed in a one-to-one correspondence? Again, that would be no, because I have an empty set which has no elements. Okay, and I'm trying to pair that with these numbers. It's not going to happen. And this one, can the square in the triangle and dt be paired with, placed in a one-to-one correspondence? That too is yes, because the square can be paired with d and the triangle can be paired with t. Okay, so this should be enough to assist you with the homework problems in section 2.2.